Okay, so let's try to evaluate the limit of an absolute value function. Let's say the limit as x approaches 4 of the absolute value of x minus 4 over x minus 4. Well, the easiest way to do this, until you can really visualize what's happening here, is to write this function in its piecewise defined form. So let's do that over here. So the thing that could be positive or negative is the x minus 4. So if x minus 4 is positive or equal to 0, well, first of all, x minus 4 can't equal 0 because the denominator here can't be 0. So I'm going to get rid of the or equals to and just say is greater than 0. So if x minus 4 is positive, then the top here is just going to be the x minus 4. Because it's already positive, I don't need the absolute values. So I end up with x minus 4. The denominator, there is no absolute value, so I just copy it down. Okay? If the x minus 4 is negative or less than 0, then the top of this will end up being the opposite of what's inside. So I'd have negative times x minus 4. And again, the bottom doesn't change because it's literally just x minus 4. So if I simplify this now, x minus 4 divided by x minus 4 is 1. Negative x minus 4 divided by x minus 4 is negative 1. And the first definition takes place if x minus 4 is greater than 0. So if I add 4 to both sides, I see that x has to be greater than 4. Add 4 to both sides on the second one, and that's if x is less than 4. So here is the piecewise defined version of this function. So now we can go back and actually evaluate the limit. So let's look at the left and right sided limits of f4. So let's look at the limit as x approaches 4 from the left of this thing, and the limit as x approaches 4 from the right of this thing. If they're equal, then we'll know the two-sided limit that we're being asked to find here. So as x approaches 4 from the left, I need to go to my piecewise defined function, and as x approaches 4 from the left, I'm going to use the output of negative 1 because that's where x is less than 4. So that's going to give me a negative 1. If x approaches 4 from the right, I'm going to use my first definition because x is greater than 4. My output there is positive 1. These are not equal to each other, so that means the two-sided limit does not exist. D and E does not exist. So the idea is this function is either 1 or negative 1, and it's 1 to the right of 4 and it's negative 1 to the left of 4. So if you were to graph this, let's see, 1, 2, 3, 4. Let's say here's 1, here's negative 1. When x is greater than 4, my y is positive 1, so it looks like this. When x is less than 4, my y is negative 1, so it looks like this. You can see that as you look at your limit, approaching from both sides, the limit going this way is not the same as the limit going this way. So the two-sided limit does not exist for that reason.